Timeless concepts from Physics Helpline. In this video tutorial, we will discuss two multiple choice questions taken from the NEET exam of 2019. The questions are as follows. Question 1. Read the question carefully. The capacitor network is shown in the figure. We are given two identical capacitors C1 and C2 having equal capacitance. They are connected as shown in the figure. There is a battery of EMF V volts is also connected, and a key having three terminals A, B and C is also in the circuit. When A and B are connected first, then C1 is charged by the battery of V volts. Then we disconnect A and B and connect B and C. Thereby the battery is out of circuit and the charge will be equally shared by C1 and C2. Due to this, there will be some loss in energy of the system. We are required to find the percentage loss of energy of the system. The options are given in the question. We are required to find the correct option. Now for the answer. In case 1, the first case, we connect A and B. Therefore, the capacitors C1, whose capacitance is C, is charged to V volts. So therefore, charge on the capacitor C1 will be equal to Q0, which is equal to C into V. And initial energy of the system, initial potential energy of the system will be equal to energy stored in C1 only, because C2 doesn't have any charge on it. Therefore, we write Ui is equal to half CV square. C is the capacitance, V is the voltage across the capacitor. So Ui is equal to half CV square. From equation 1, we get V is equal to Q0 by C. Putting this and simplifying, we get Ui is equal to Q0 square divided by 2C. In the second case, A and B are disconnected and we connect B and C. The two terminals B and C of the key are now connected. Therefore, the two capacitors C1 and C2 are now connected and the battery is out of circuit. Since the capacitance of C1 and C2 are equal, therefore charge will be equally shared by C1 and C2. Initially the charge was Q0, therefore each of them will have charge equal to Q0 by 2. Therefore we write charge on capacitor C1 is equal to charge on C2, which will be equal to Q0 divided by 2. Therefore, finally, the energy stored in each capacitor will be using the formula Q square by 2C. Energy stored in a capacitor is equal to Q square by 2C. For each capacitor, the charge is Q0 by 2. Therefore, final energy stored in each capacitor will be equal to Q0 by 2 whole square divided by 2C, which on simplification will be equal to Q0 square divided by 8C. Therefore, final energy of the system of two capacitors will be equal to UF, which is equal to 2 into Q0 square divided by 8C, which is equal to Q0 square divided by 4C. From equations 2 and 3, we observe that UF is equal to UI divided by 2. So we want to calculate the percentage loss of energy, which will be equal to UI minus UF divided by UI into 100. This factor is equal to 1 by 2 into 100 will give us 50. Therefore, percentage loss in energy is equal to 50%, which is the answer to question 1. Therefore, the correct option is D. Now for question 2. It is a resistance network similar to a Wheatstone bridge. The resistances are 20 ohms, 30 ohms, 30 ohms and 20 ohms. And there is a ideal voltmeter V is connected, and a cell of EMF 2 volts is also connected as shown in the figure. We are required to find the reading of the ideal voltmeter V. The options are given in the question. We are required to find the correct option. Now for the answer. It is given in the question that V is an ideal voltmeter. Therefore, current through an ideal voltmeter is always 0. Therefore, we now want to calculate the potential difference across ACB, upper branch. Since the battery is connected between the points A and B, the voltage across the upper branch ACB will also be equal to 2 volts. So we write VACB is equal to 2 volts, and resistance of the upper arm RACB is equal to 20 plus 30, which is equal to 50 ohms. Therefore, current through the upper branch IACB will be equal to voltage divided by resistance 2 divided by 50, which is equal to 0.04 amperes. Now, we want to calculate the potential difference across the points A and C. So, VA minus VC is equal to the current through that branch is 0.04 amperes multiplied by the resistance between A and C is 20 ohms. So, 0.04 amperes into 20 ohms, which gives VA minus VC is equal to 0.8 volts. Now for the lower branch ADB. Since A and B are connected across the battery, the voltage across ADB is also equal to 2 volts. And resistance of the lower branch ADB is RADB is equal to 30 plus 20, which is equal to 50 ohms. Therefore, current through the lower branch IADB will be equal to voltage 2 volts divided by resistance 50 ohms, which is equal to again 0.04 amperes. So now the potential difference across the points A and D, VA minus VD, will be equal to current in the arm is equal to 0.04 amperes multiplied by the resistance between A and D, which is 30 ohms. Therefore, VA minus VD will be equal to 1.2 volts. Now VA minus VC is equal to 0.8 volts and VA minus VD is equal to 1.2 volts. And we want the voltmeter reading, which is connected between the points C and D. Therefore, we want the potential difference between the points C and D. That can be obtained by subtracting equation 1 from equation 2, because equation 1 has got 0.8 volts and equation 2 has 1.2 volts. So, 2 minus 1, equation 2 minus equation 1 will give VA minus VD minus VA minus VC. And on the RHS, 1.2 volts minus 0.8 volts. So, VA and VA gets cancelled. Therefore, we get VC minus VD is equal to 0.4 volts. Therefore, the voltmeter reading will be equal to 0.4 volts, which is the answer to question 2. Therefore, the correct option is B. This completes the answer to both the questions of this video tutorial. Thanks for watching. If the video is helpful, then please like, share and subscribe.